Chapter 4, Topic 4.5, Motion in 2 and 3 dimensions. In order to understand the relative motion or velocity of 2 and 3 dimensions, we need to discuss first the relative motion in 1 dimension. Let's take the example of the person sitting in a train moving east. If we choose east as our positive direction, therefore we can write our velocity of train with respect to the earth equals to 10 miles per second I hat. This sign signifies to our object with respect to its reference frame. Let's now say the person gets up out of her seat and walks toward the back of the train at 2 meters per second. So since ang person gapaadto sa west, which is our negative direction, meaning ang velocity of the person with respect to the train is equal to negative 2 meters per second. Now let's continue on calculating the velocity of person with respect to the earth. In order to get the value of the velocity of person with respect to the earth, we need to follow this formula. Of person with respect to the earth equals to the velocity of person with respect to the train plus velocity of the train with respect to the earth. That here the value of the velocity of the person towards the train, which is the negative 2, plus the value of the train with respect to the earth is equals to 10. So negative 2 plus 10 is equal to 8 meter per second, and this is our value of the velocity of the person towards the earth. Relative velocity in 2 dimensions. We can now apply these concepts to describing motion in 2 dimensions, considering a particle P and reference frames S and S prime. From this figure, makita nato nga ang position vector in frame S is the position vector in frame S prime plus the vector from the origin of S to the origin of S prime. It is stated in here that the relative velocities are the time derivatives of the position vectors. Therefore, we need to replace the relative velocity into letter V or velocity. We'll use this relative velocity equation in order to connect 2 reference frames. So we have an example here. A truck is traveling south at a speed of 70 km per hour toward an intersection. A car is traveling east toward the intersection at the speed of 80 km per hour. So now, what is the velocity of the car relative to the truck? Gamit ang velocity addition rule, ang relative motion nga ang atong gipangita kay the velocity of car towards the truck equals the velocity of car with respect to the earth plus velocity of the earth with respect to the truck. In order para masolve ang atong given problem, we are needed to draw a vector diagram of the vector equation velocity of a car with respect to truck equals velocity of the car with respect to the earth plus velocity of the earth with respect to the truck. Since given ang atong value aning duha, these blue lines here indicates the velocity of car with respect to the truck. So mao ni ang ato ang isolve. Okay. From the vector diagram below, we can solve now for the velocity of the car with respect to the truck. Velocity of a car with respect to the truck is equal to the square root of 80 km per hour square plus 70 km per hour square. Kung atong i-calculate, nga mag-equal siya into 106 km per hour. And to simplify, theta equals tan to the power of negative 1, 70 over 80 equals to 41.2 north of east. Mao ni siya ang value nga atong gipangita.